Well, hello once again. I was confronted with this question a couple of days ago. It says, consider the sequence Sn, where the term Sn is defined as the sum from I ranging from 1 up to n of 1 over I. Well, this is nothing else but the partial sums of the harmonic series. The question is that whether this sequence is bounded above. In other words, is there a constant such that C such that Sn is less than or equal than C for all n greater or equal than 1. Right? That's the question that we'd like to address. Now, I'm going to provide some intuition, and then at the end, we'll see how to proceed in general terms. So what I want to do is to start with some experimentation about this sequence. So, well, note that, for example, S1 is simply the sum ranging from 1 up to 1 of that expression, which reduces to 1 over 1, which is 1. S2 is the sum ranging from 1 up to 2 of 1 over I, which is nothing else but 1 plus 1/2. Right? For example, S3 is the sum ranging from 1 up to 3 of 1 over I, which is nothing else but 1 plus 1/2 plus 1/3. Now, if we examine the very few terms of this sequence, we see that this is an increasing sequence, but it increases slowly. So the question that we have here is, it's a natural one, right? Could this be bounded? Well, here's an idea. What I want to do is explore the terms with an index 2. So imagine I have this S of 8, for example, and S8 would be the sum ranging from 1 up to 8 of 1 over I, which is nothing else but 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8. Now, what I'm going to do is group these last 4 terms of the sum, and I'm going to replace them with something smaller. So each of these 3 is going to be replaced by 1/8. That way, I have the following inequality. Then you may say, look, these 4 terms that we have here are nothing else but 1/2. This is 4/8. So in other words, this is equal to 1 plus 1/2 plus 1/3. So I'm missing 1/4 here, plus 1/4 plus 1/2. And then, look, I'm going to repeat the process. So here, I'm going to group these 2 and perform a similar replacement. So now instead of replacing this by 1/8, I'm going to replace it with 1/4. And what I will get is this 1 plus 1/2 plus 1/2, equality here, of course, plus 1/4 plus 1/2, right? Replacing this over here. But again, I observe that this is nothing else but 1/2. So what I have here is nothing else but 1 plus 1/2 plus 1/2 plus 1/2. So I wonder if a similar argument might be applicable to the following. Would be 1 plus 1/2 plus 1/2 plus 1/2 plus 1/2. Similarly, I will have S32 would be greater or equal then 1 plus 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So there seems to be a relation here between the expression that we have here in terms of a power of 2 and the number of times that we can replace, or the number of times that we will write 1/2 in this inequality. This is going to give us intuition to actually demonstrate that in fact the the harmonic series is unbounded. Let me know if you would like to see the details in a subsequent video. Okay, take care.